This video will serve as an instructional tool. This video will serve as an instructional tool in order to find the concentration of an unknown solution. In order to find the concentration of an unknown solution. The student in the video has collected samples of several from the same stock solution, all of which are from the same stock solution. This will allow the dilutions to be read on a spectrophotometer. This will allow the dilutions to be read. Notice how he is looking at the cuvette. Notice how he is looking at the cuvette. This allows the student to transfer an accurate and sufficient amount of solution into the cuvette. Sufficient amount by following proper lab procedure. By following proper lab procedure, the student will not overflow the cuvette. This is also a good time to review Beer-Lambert law. This is also a good time to review Beer-Lambert law. Is the law that even allows us to find the unknown solution. The law that even allows us to find the unknown solution concentration. The concentration of the chemical. It states the positive correlation of the chemical. It's the positive correlation. Here you can read all of the variables that are involved with Beer-Lambert variables from absorption with Beer-Lambert law, from absorption to molar absorptivity. Now that we have the samples, we must use the spectrophotometer and select the blank cuvette. This cuvette has all of the carrier solvents except for the substance being measured. Now, wipe down two opposite, as opposed to adjacent, sides of the cuvette with the lab wipe. Then place this blank cuvette into the spectrophotometer with the clean sides in the beam. Close the spectrophotometer's lid and zero the machine. If done correctly, the red number at the top left should either equal 0 or a very, very close number. The importance of zeroing the spectrophotometer is that the absorbance values could be distorted due to other substances which would compromise the data. From here, replicate the same process with the other cuvettes. Although, instead of zeroing the spectrophotometer, we will read the solution on all wavelengths. The importance of zeroing the spectrophotometer is that the absorbance values could be distorted due to other substances which would compromise the data. From here on, replicate the same process with the other cuvettes. Although instead of zeroing the spectrophotometer, we will read the solution on all wavelengths. This process gives us the ability to observe purity and determine the best wavelength to scan the dilutions, generally known as the lambda max. The lambda max is the wavelength where the most light is absorbed into a solution.
Alright, so if you guys want to zoom out for this, your peak. Okay, I'll be over there in a second. Your peak's right.
We recorded the absorbance values and found the final concentration values, which should all be observed here. Lastly, but most importantly, we cleaned our area up so that Haley wouldn't point at a pure spike. And this has been Spectrophotometer, Copper and Math. I hope this has been instructional and helpful for any students or VA that are listening.